The last problem we're going to look at is a rate in rate out problem from 2012. So we're given a table, and this is a graphing calculator problem, by the way. So we're given a table and where we're given the temperature in degrees Fahrenheit and the time in minutes. So S is use the data in the table to estimate W prime of 12. So we have to find the slope at 12 and then using correct units interpret the meaning of your answer in the context of this problem. So let's go with A. W from 12 is 67.9 minus 61.8 over 15 minus 9. The answer to this, once we put in the calculator, is 1.016 and degrees Fahrenheit per minute. So now the second part of this is interpret the meaning of your answer. So at T equals 12, so we're dealing in water in here, okay. So at T equals 12, the temperature of water is increasing, because this is positive, by 1.016 degrees Fahrenheit per minute. So this is our interpretation. This is the answer to A. Let's erase this and look at B. B says use the data in the table to evaluate this interval and then use the correct units interpret the meaning of this. So we have to evaluate the interval from 0 to 20 and W prime of T, okay, dt. So this is where it comes our fundamental theorem of calculus. So W of 20 minus W of 0. So that is 71 minus 55 equals 16 degrees Fahrenheit, because we took the integral of it. So this is no longer a rate. So the meaning of this is how I write it: from 0 to 20, the interval from 0 to 20, the water temperature, is or was 16 degrees Fahrenheit. So this is my interpretation. Now let's look at C. C says for the time interval 0 to 20, the average temperature of the water in the tub is this. Use a Lefft-Riemann sum with 4 sub-intervals to approximate this. Does the approximation overestimate, underestimate? Okay. So from 0 to 20, we're using a Lefft-Riemann sum from. So 0 to 20. T dt. That's our problem, right? Yes. Oh, and don't forget this. This is the important part. 1 over 20. Okay. Are we supposed to interpret the meaning of this? No, we're not supposed to interpret the meaning of this. We're just given this. So we're approximating using Lefft-Riemann sum, and never forget 1 over 20, because this is what they gave us. So 4 minus 0 is 4 times 55. 4 times 55 plus 9 minus 4 is 5 times 57.1 plus, already in the bottom, 15 minus 9 is 6 times 61.8 plus 5 times 67.9. So 5 times 67.9. Yes. So we get 1 over 20 times, once we put in the calculator, we get 12,015. Okay, it's a terrible one. 10.8, which equals to 60.79 degree Fahrenheit, not Fahrenheit per minute, because this is no longer a rate. Now, is this an overestimate or underestimate? So W of t is increasing, and this is a left Riemann sum. So this is an underestimate. So we're gonna say this is an underestimate because W is increasing and we're doing left Riemann sum. There we go. So this is the answer to C. Now let's look at D. D says for the time intervals 20 to 25, the function W that models the water temperature has first derivative given by this. Based on the model, what is the temperature of the water at time t equals to 25? So we know from other problems we did, like position, if they're asking us for a position at a specific time, we need to know the initial condition or the initial position. So in here we're asked to find the temperature at a specific time, that is 25. So we're going to use the same strategy in here. Okay, so we're going to use the same strategy in here. So W of 25. So in this case our initial is 20. This is W of 20 plus the integral from 20 to 25 of W prime of t. So W of 20 is about 71.0. And once we put in the calculator and we get the interval, the value, which is, we put the equation in the calculator and we hit math 9 and we put the two intervals and we get 2.043. So we add this 2 and we get 73.043. And what's the temperature? Since it's the temperature, let's say degrees Fahrenheit. And that's the answer to D.